Assalamu alaikum everyone. Today we are going to conduct lecture number 13 and today's topic is instruction set. So let's proceed to the lecture. Okay, the topic is instruction set, and instruction set can be defined as basic operations or choices of words which are specified by a programmer. So one can also say the number of choices of different keywords which are available for a programmer while he or she is programming microprocessor 8086 or 8088. That set of choices is basically known as instruction set. So instruction set can be defined as set of all possible instructions or statements. So whatever the number of statements or whatever the number of instructions available, they are grouped in one set, and that is called instruction set. In total there are 117 basic instructions, and these instructions are organized in several groups. Why they are organized? Because to understand the difference of usage and application, each of these instruction applied on several operands or data operations uh, differently, so their different usage categorize themselves in different several groups. So these groups are basically kind of the categories of different groups in instruction set. So in last slide we learned that there are different groups of instructions within one instruction set. So let's see what are those groups. Data transfer instruction set, arithmetic instruction set, logic instructions, string manipulation instruction, control instructions, process control instructions. So in total these are basically how many groups? Set 6 groups of instruction sets. So these different groups we will study in detail one by one, or try to cover their different usage in different operations. So data transfer instruction set, this is very first uh, instruction set group. We learned there are 6 different groups available in instruction set of 8086 or 8088 microprocessor. So very first instruction group is basically data transfer instruction group. So it is normally identified by move instruction, and we will learn this thing. So in this picture one can clearly see these data transfer instructions. For example, move, push, pop, exchange. Push and pop, we have already seen their applications while we were learning stake segment and pushing different values and popping out different values from stake. So we learned these two instructions. We will learn these instruction in instruction set group as well, but today's most important instruction which we are going to learn is move. And move is very powerful tool because it is normally the main instruction which can easily explain different aspects which are available in variety of instruction. So if one can understand move statement in all aspects, he or she can actually cover all possible instructions. So data transfer instructions are normally identified by this move instruction. We see here different number of bytes. These are basically bytes. If you closely look at them, 0 1 2 3 4 5 6 7, so these numbers indicate this is a byte, this is again a byte, this is again a byte, this is again a byte. So if you closely look in the very first row, here in the very first row there are 4 different bytes. Similarly in the next row we can see that there are 6 different bytes. So these instructions vary from one aspect to another aspects, and we are going to learn all those aspects while we are going to learn assembly language programming. So we will be dealing these things in detail, but this is just to show the complete picture of data transfer instruction. So we will learn about these things, how different bytes are organized, how different datas are basically packed inside this format, how they define the size of instruction, either they are 16-bit or 8-bit. So everything is embedded in these machine codes or in these binary informations. So but we will hold on those things for a while. Right now we are trying to learn the move statement. Move statement is not only a powerful tool, but it is also a very important instruction because it can explain a very good aspect of assembly language programming, which is known as addressing mode. Addressing mode is something which we are going to deal in a separate lecture. So hopefully once we will finish this lecture, so next coming lectures, probably 2 or 3 lectures, will be based upon only on addressing boards. So these things are coming in our coming lecture. Wide range of operands, this thing just we are going to explain in very next slide. Okay, this is something which is important point, and I mentioned it here deliberately. Leads towards 28 different machine level codes. As you can see, there are different aspects of programming which are combinations of ones and zeros, and every bit variation leads to different aspect, or leads towards different scenarios. So a move statement single or solely responsible for 28 different machine level codes. How we are going to learn when once we are going to deal machine language translation. Okay, move instruction we are formally going to introduce with move instruction. As I explained, it's very important because it leads toward uh, data transfer instructions variations. Okay, how its format is as follows, which is move d comma s. This is a very unique thing. This is a format. Every time you gonna use move statement, you need to follow this particular uh, format. What is it? This, first of all, you're gonna write this move, which is what? Mnemonic. If you remember the last lecture in which we have covered assembly language programming introduction, that thing is basically called what? Mnemonic. Then these are basically operands. This is our opcode part, this is our operand part. So let me just use different color so that you can remember. That is our, okay, pen, okay, that is opcode, and this part is basically what? Operand part. Okay, its operation described as, this is our source operand. We have learned this thing earlier, that is our source operand, and the first thing which comes after the opcode is our destination operand. So what happens when one is going to use this instruction? Whatever the value in the source operand, it is going to transfer into the destination operand. So that is the information transfer matrix. I mean, this is how a value will transfer from source operand to destination operand. It can transfer a byte-wise information, and it can also transfer a word-wide information. For example, one can write move BH comma CL. Remember, this is 8-bit information, this is 8-bit information, so 8-bit of information is going to transfer, right? And if we are using, instead of BH and CL, we can use simply BX and CX. That will completely convert that thing into 16-bit operation. So that data transfer can be about 16-bit or word wide, or it can also be 8-bit or simple a byte wide information. Furthermore, operands can be internal registers or memory. So these operands, in this example which I take here, let me erase this extra stuff. In this example, I use what? Both of these are base. PX is internal register, CX is also internal register. So both of these operands are what? Internal registers, but in these registers or these operands could be some internal memory as well, and that we're gonna learn in addressing mode as well. Okay, this is something that I was talking about 2 slides back when we discussed there are variety of operands available. So we can see that these are different options available for destination. These are different options available for source operand. For example, destination can be memory, right? If you remember, memory is connected to 8086 or 8088 microprocessor, so any of those memory slot can be used as a destination operand while one is applying move instruction. Or it can be accumulator. If you remember, accumulator is another name for what register? AX. Remember, AX. Register can be anything, right? Okay, before we proceed, one need to know that this is going in that direction. So accumulator to memory, that is possible. Memory to accumulator, it is also possible variation. Register to register, memory to register, register to memory, something immediate to register. That thing we gonna learn uh, while we are going to discuss addressing mode. But immediate is, one can simply consider that it is direct data, whatever we want to provide. We're going to explore these things more in detail. So there are various number of operations or range available for data operands while one is dealing with move instruction. That is why move instruction is always considered a powerful tool. Okay, this slide is just kind of extension while we are trying to give complete format, complete uh, meanings of everything. So first thing which is mentioned here is basically what is the mnemonic or what is the keyword for move instruction. That is mov move, right? Next thing, that is the meaning of mnemonic. I mean, what that keyword actually works for. So this keyword, which is mov move, actually work as move. Move means transfer something from some place to another place, and that is the actual format that we are going to write in assembly language programming, and that will be move d comma s. And we have already explained it that d is basically destination and that s is basically source operand, and that gonna be the flow of direction from source towards destination. So every time you're going to write some things in source operand, that information will get copied and pasted in destination operand. Okay, that last column is very important, and one cannot deny or cannot complete aspects of move instruction that it is powerful tool because it does not affect any flag registers. If you remember, flag register we have discussed, or status register we discussed different 9 bits, or out of those 9 bits 6 were kind of flag registers or status bits. So those status bits or flag bits are never affected by these move instruction. So whenever you want to just move or replicate one stuff from one place to another place, you can use this move command because it will not affect any flag register. So conditions or different statuses within the within the microprocessor will remain same. So these are very important aspects of move instruction. I hope I have clearly explained them. Okay, in this slide we are going to discuss some example with certain logical diagram which explains the depth of move statement. I hope this diagram can be seen clearly in this window. I have seen this picture from your textbook, which is 8086 or 8088 microprocessor programming interfacing software, hardware and applications by Avtar, Singh or Walter A. Triebel. So this is a textbook application, textbook example. So we're gonna do it. In this example, we see here microprocessor, and if you remember, that is basically software model. We are not connecting with the hardware model, which was basically architecture. We are dealing here with software model. We can clearly see that instruction pointer, code segment, data segment, stake segment, extra segment. So these are basically what segment registers. Similarly, some data registers are shown here, which is AX, BX, CX, TX, and similarly pointers and index register, stake pointer, base pointer, source index, and destination index. These are clearly visible here in this diagram. So this is basically software model of 8086 or 8088 microprocessor. Well, here we see memory. and we don't need to seek full memory. We are just observing some chunks of memory. Why these chunks are shown, we will just gonna understand in a while. First of all, you have to look at this IP and CS. Both of these registers are very important. While one is going to try to what? One is going to try to deal with code segment, because CS provides what? If you remember, CS is what? Base base address, if you remember, for code segment, right? Similarly, IP is what? Offset. IP is what? Offset of. So they are actually calculating the actual address or actual uh, next instructions address. So if you see, IP value is what? 0100, right? And CS is basically what? 0100. So what we gonna do to make a physical address? We have to multiply this value, which is CS value, by 10, and whatever the result, we gonna add 0100 in it. So if you combinedly solve it, it becomes 01100. I hope you can translate it. I will just repeat. That is basically CS value. This is our IP value, and both these values are shown here. One can clearly see here. So 0100, 0100, both these values are 0100. CS value will get multiplied by what? 10, so it will become 01000, and once we are going to add 0100, that total will become what? 0110, and that is what? That is the physical address of next instruction. So that is our memory. We're gonna search for this location, this address 0100, and that is this location. If you see, this address is what? 0100. Remember, that means this is the address of the next instruction. So remember one thing more, if you remember it, that is 16-bit microprocessor. So we gonna need 16-bit information, but this is what? Single slot. So we need to take the next slot as well. So that is basically what? 8C and CA. This is something written in machine language or in hexadecimal form of machine language. These are ones and zeros, but we cannot understand what does it mean. But if you try to convert that thing into assembly language, that is basically written here. So that part is basically in assembly language, and this part is what? In machine code. So in assembly language, we understand it's quite easy. Move dx comma cs. That means whatever the value of cs, you need to transfer that value into dx. So let me clean this whole stuff before we proceed further. We need to do what? Let me clearly written again. Move dx comma cs. That means whatever the value of cs is, it is going to get copied inside the dx. Cs value, what is the value of cs? That is 0100. What is going to happen? It will get transferred into dx. So let's see what happened after the execution of this instruction. Look, that is what? 0100, that is the value of cs, and that has been copied here in dx. That's thing I wanted to show. So just let me tell you that these two diagrams are, this is the before execution of instruction, and that is after the execution of instruction. The same diagrams are shown, same thing is represented, but this is just the left side is before the execution of instruction. What instruction? Move dx comma cs, and that is the after execution of this instruction. So what we happened, whatever the value of CS, it was basically 0 100, it is going to shift in DX, and that has happened here. I hope I have explained everything in detail. If you haven't understand it, we can deal it in online session as well. Okay, that's it from this lecture. I hope I have explained everything in detail clearly. If you have got any question, please note them down, and we are going to deal with those queries in online session. Thank you so much for listening.